Hello everyone! You learned about implicit and explicit type conversions. So in this lesson, we'll use all the different ways of converting data types to reinforce what you learned. Let's get started. Exercise 1. You're analyzing a courier's trip. The user enters the distance traveled in kilometers and the travel time in hours as integer values. Calculate the average speed so that the result can contain a decimal part. First, we ask the user to enter the distance and the time. According to the task, both values should be integers, so we use the int type. Next, we need to figure out how to get a floating point result. We need to divide the distance by the time. It's the standard formula we know from school. But since both the distance and the time are integers, the result of the division will also be an integer. What we need, however, is a floating point value. There are several ways to solve this. For example, we could create additional variables of type double, copy our values into them, and then divide those floating point values. But why introduce unnecessary names into the namespace and allocate extra memory? It's better to use an implicit type conversion. To get a floating point result, it is enough to convert at least one of the operands to a floating point type. It can be either the distance or the time, it doesn't matter. We could convert both operands, but that would only make the code harder to read. And of course, the result should also be stored in a variable of type double, otherwise the conversion would be pointless. Let's run the program and see what it prints to the screen. Exercise 2. You're writing a small diagnostic program for a keyboard. The user enters a single character. The program should print the character itself and its numeric code. Here the situation is simpler because we only need one variable. We create it and enter the value, but there are still several ways to solve the task. In my version, I take a variable of type char and explicitly convert it to int. Notice that this time I didn't use static cast. I used another casting syntax just for variety. However, in modern C++, it's generally better to use static cast, and that's what I'll use in future lessons. But the thing is, we don't actually have to use an explicit cast here at all. The char type is lower than int in the type hierarchy, so converting char to int doesn't lose any information, and the compiler won't even give us a warning. Let's run the program and take a look at the output. Exercise 3. You're creating a program for tracking the length of a roll of material. The user enters the length in meters as a decimal value. The program should determine how many full meters the value contains by completely removing the fractional part. If you have a floating point value with digits after the decimal point and you want to get only its integer part, you need to convert that value to an integer type. That's exactly what I do here. First, I enter the number, then I get its integer part and store it in a separate variable. After that, I print both values to the screen. By the way, think about how you could get only the fractional part of the number. You already have enough knowledge to figure that out. You can try printing the fractional part as well. Let's run the program. And that's it for this lesson. Thank you for watching. I'll see you in the next one. Bye.